All right, so for 2-4, we're still continuing our solving equations, or solving rational equations. Let's see if I can spell right. So I want to go through, let's see, 1, 2, 4 examples, 2 of which we're going to star because they're like ones on your test. And again, these are just more types of the same solving equations. We're going to have some fractions mixed in as well as some negative exponents so we can see what to do when we have negative exponents or even just fractional exponents. So we're going to kind of start mixing them all together so you can see how the process is the same with maybe 1 or 2 adjustments depending on the type of problem. So if we look at our first example, we'll see that we have, oops, that should be a minus sign. We can see that we have 2 fractions, a constant, all equaling 0. So I don't have any negative exponents here, so I don't have to worry about that. I also don't have any fractional exponents. So because I have the fractions, this is where we're going to look for the LCD and multiply each term by that LCD so we can cancel out denominators. So when looking at our denominators, I'm going to take the highest power of each base, which in this case would be x plus 1 squared. So when I multiply each one of these by x plus 1 squared, whoops, times x plus 1 squared times x plus 1 squared, and don't forget we even have to do the other side of the equation by x plus 1 squared. Now when we multiply, we get the denominator on the first one to cancel completely. This here is to the first power, so I'll have that one cancel with 1 of the x plus 1's, leaving me with 1 left over to multiply by 9. We don't have anything to cancel the last one with, so that's just going to stay 5 times x plus 1 squared, and anything times 0 is 0. Now from here, you could FOIL things out, combine like terms, and then try to factor. Something that you might also notice, and this is what I'm going to do, is I notice that I have a base squared and a base to the first and a constant. This leads me to be able to do a u substitution. So if I say let u equal x plus 1, then u squared would be x plus 1 squared. So this allows me to simplify my factoring to 2 minus 9u minus 5u squared, so that I don't have this polynomial in a polynomial. It also helps me avoid multiplying things out because I noticed I had the same base. If we didn't have the same base here, then we would have to do the multiplying out. So this one is only able to be done the u substitution because we had the same base, 1 being squared, 1 being to the first power. So now I can double bubble this polynomial. So let's see, 2 and 1, I need to add up to negative 9. So if I do minus 5u and plus u, I'll get negative 10u plus u will give me negative 9. So then when I take each one of these and set it equal to 0, I'll get u is equal to negative 2. And u is equal to 1/5 after I solve each of those for u. So now what I need to do, now that I know what u is, I have to remember to go back and plug those values in for u and actually solve for x. So if I plug in negative 2 for u, x is actually negative 3. I'm also going to plug in 1/5 for u, and when I subtract 1, I end up with negative 4/5. Oops, 4 over 5, not 4 over 4. and these would be your two answers. And so we do still have to look at our restrictions. So the only value that would make my denominator 0 would be a -1, which isn't what I got, so both answers would suffice. Okay, you have one like this on your test, so this is one of our starred ones that you want to make sure you know how to do. So if you have any kind of questions, make sure you ask, so that way we can get it clarified, so when you see it on your test, you know what you're doing. Okay, number 2. This one has some fractional exponents. X to the 1/4 minus 12x to the -1/4. Sorry, that's going to look a little weird. Didn't leave enough room. -1/4 minus 1 equals 0. So when I look at this, my brain goes to either substitution, so trying to see do I have something, a base and that base squared in my problem, and if I don't, then I need to think I have a negative exponent and a positive. So now I might actually have to turn this into a problem like number 1. So since I don't have, like let's say I would say u equals x to the -1/4. When I square that, I'm going to get -1/2. I don't have a -1/2 in my problem. So u substitution here is not going to work. What I will need to do is rewrite this like we did in a previous unit, or previous section, sorry, with the x to the 1/4 on the bottom. So in other words, make your negative exponent positive. Now this turns it into a problem that's like the first one we just did, where we need to multiply by an LCD. So if we look here, our LCD would be x to the 1/4, the only thing that's in our denominator. So we'll multiply everything by x to the 1/4, including the 0. So when we do 1/4 times 1/4, we're adding the exponents, so that means we're going to end up with x to the 1/2. Over here, these are going to cancel out completely, and here we'll have just x to the 1/4, and anything times 0 is 0. Now when I look at this, I'm going to rewrite it so that it's 1/2, then x to the 1/4 with my constant at the end. So here I do see that if I were to call u x to the 1/4, then u squared, so 1/4 squared is x to the 1/2. I do have both of these terms in my problem, so I can do a u substitution if I wanted to. If you don't like u substitution, then you can, and you understand how to break it apart with fractional exponents, you can do that as well. I'm going to focus on the u substitution mainly because there is a method next year in calculus that relies on you guys being able to notice u substitutions or substituting in other values. So I'm going to continue doing u substitution because it should help you in your future math classes develop this whole idea. So for x to the 1/2, I'm going to put a u squared, and then here I'll put minus u and then minus 12. So I have something that's a little bit nicer to factor. So I can do my double bubble, u minus 4, u plus 3, and we'll get u is equal to 4 and -3 when we set each of those equal to 0 and solve. So again, those are u's. We need x's. So I'm going to go and say 4 is equal to x to the 1/4, and then I'll also have -3 is equal to x to the 1/4. So to get rid of the 1/4 power, we raise to the 4th power, because 1/4 times 4 is 1, giving me just x, and then 4 to the 4th, I believe, is 196. 196. So that would be one solution. Now over here, again, can we take the fourth root of something equaling a negative? The answer is no. So this would be a no solution to that half, giving us our only solution of 196. So again, from the start, I was looking to see if I had this u substitution at the very beginning. I didn't have it. But I did have a negative exponent, which I can't have, so I moved that to the denominator and then did my LCD like we did up in number 1. After doing the LCD, I looked for a u substitution again, and that's where I saw that if I let u equal x to the 1/4, that u squared, or x to the 1/4 squared, is x to the 1/2, which also is in my problem. So that allowed me to do a u substitution to solve. Put a star next to this one, because again, you have a similar one that you'll have on your test, like this, that you'll need to know how to do. So again, if there's a step where I lost you or you're still not sure about why, please write it down and ask it in class. Okay, our third one. This third one we're going to go over is one that we commonly get stumped on. So I want to show you how we go about it. That's supposed to be a plus. So when I look at number 3, I think, oh, I can just distribute the x, move everything over, factor, solve, get your answers. Yes, that works. Okay? Takes more steps, takes more time, but it works. What I want to note to you guys, so that if you see this in the future, you have another way you could do it that could make things go quicker, is I'm going to group together the x plus 5. And the reason I'm going to group together that x plus 5 is because I notice on this side I also have an x plus 5. So that if I subtract that whole group, so subtract that whole group of x plus 5 to both sides. So I'm left with nothing on the right, and now I have it being subtracted as a whole group on the left. I notice I have a GCF. They both have this x plus 5. So if I take out that GCF of x plus 5, I'm left with an x in the first spot, and remember we need the 1 placeholder, and we have our factored form. So if you ever notice that you have a grouping on one side and you have the potential to group something on the other side so that you get this GCF idea, go ahead and try that, because if we have it, then we tend to have this grouping situation that tends to make things go a little bit quicker. Because now I can solve by setting each factor equal to 0, and I would get -5 and +1 as my two solutions. Now, had you gone and FOILed everything out, distributed, combined like terms, and done it, you would have gotten the same answer. You just would have had more steps to go through. So our last one for today is going to be very similar. So we'll have x minus 4 squared times x plus 3 equals x minus 4 squared. So we have the same idea. I have the same grouping on either side. So if we think about it the same way we did number 3 and move this entire grouping to the other side. So I'm going to subtract that whole group of x minus 4 squared to the other side. Now I have this GCF of x minus 4 squared. So when I take out that GCF of x minus 4 squared, I'm left with an x plus 3 in this first spot, and then I have to have my 1 placeholder in the second spot. So now I just need to combine like terms in my second parentheses to become x plus 2, and I can set each factor equal to 0, and I end up with 4 and negative 2. So again, it's just this idea of, again, a polynomial GCF that we can take out. Again, if you wanted to FOIL things out, multiply them together, combine like terms, and all of that, yes, you would eventually end up at the same spot, but you'd be going through it in a much longer way. So on any of these, if you have questions that you want me to go over, or you're not sure about any particular step, write it down and please ask at the beginning of class.